Hello, we are Team Wigglytuff. My name is Gözde and our project name is Sentiment Analysis on Sentences. We use Google Emotions dataset for this project. As you can see here, our dataset has many columns including sentiments. And for the sake of our exploration, we decided to group them in three categories. First, which is positive, negative, and ambiguous. We defined the functions for that, and then this is the bar plot of our whole data, and then this is the grouped bar plot of our data set, which is positive, negative, and ambiguous. This is the pie chart including the neutral ones. For our data set, for our project, we decided to use 6 different emotions, which is anger, fear, joy, sadness, surprise, and neutral. We defined the function for that, and this is a pie chart of the new grouped data set. The joy is the most significant one in here, and the fear is the least. And in here, this is showing the heat map of our whole data set. In the second part, Büşra will be telling you how we prepare our data.
At this part, we take the dataset, and dataset have a column which says if the rows clean or not, and we just take the clean ones. And after that, we group our data into 6 different categories at this part, which is anger, fear, joy, sadness, surprise, and the others, and split the data to text, train, and validation sets. At this part, we write arena from scratch. Firstly, we take group train dataset, which we prepared at the previous part, and we prepare it with tokenizer and limitizer functions, which is used to decrease the versions of the words to 1, which is the root of the word. And we make padding, because input's length have to be same to give it to model. And this shows the padding. After padding, we have to convert our text to integer to make them input to model. This part shows the parameters of our models. We use softmax function as an activation function to our output layer. This function make forward pass and calculate the output of input. After calculating our output, we calculated loss and make back propagation. And this is the part we make training. We use 3 epoch to train our model. After training, we get the trained model and we test our model with the text input. And our accuracy is 0.29.
After we train our RNN Scratch model, we decided to use LSTM and a backend for improving accuracy of our models. So we decided to use PyTorch for that. And this is the definition of our model itself. This is the parameters, and this is a forward function. We use bidirectional LSTM and also MLP for deciding the output. And this is the LSTM class. We also defining our parameters and the forward function. And this is the MLP, and the same things happening in here. We use a redo for activation function. And then this is we used train model function for train set, and we calculate the total epoch loss and also total epoch accuracy in here, and also we with the predictions. And then we also created another function which is called evolve model for validation set. The same process is happening in here. We load our data with load data function, and we tokenize the data with split function here. And for tokenize and also lower casing and other stuff, we decided to use PyTorch for that, and the data library, the field function in here. We also created batches in that part, and we are using the train, validation, and test data which we prepared in the previous sections. We also decided to use Glowy embeddings for better results because Glowy has some suitable weights for the English words. And then we defined our parameters, as you can see here. The number of classes is 6 because we are trying to guess 6 different sentiments. And then this is the training part. We decided to use an algorithm that uses a variable which is called number of bad epochs. We decided a bad epoch as if the validation loss is bigger than the least loss. This is considered as a number of bad epochs. For stopping the training, we had to get bad epochs for 10 times in a row. If it's happening, the training is stopped. Also, if the epoch is 100, training will also stop. For our case, our model trained for 42 epochs. As you can see here, training accuracy is 72.66%, and our validation accuracy is 15. And this is how our model looks like. And we also test our model, and the test accuracy is 50, which is very close to our validation set. We decided to test some sentences in here. This is the function for that, and we defined some sentences. For example, I love you, which is considered as joy in our data set, is also considered as joy with our model prediction. And also, for example, are you kidding me, really, sentence considered as joy in our data set, but for our model, but in our data set is considered as anger. This sentence is also hard for humans to understand without tone, so our model cannot make good predictions in that cases. And this is the training stats of our model, and this is the plot of our accuracy and loss. As you can see here, training accuracy is getting higher for each epoch, but the validation set is not improving that much. In line with that, training loss is getting really lower, but the validation loss is not that differ. Thank you for listening us.